Illustration of subset sum problem. In the last lecture, we learned about subset sum problem and we also learned how can we solve this problem. The same algorithm we are going to illustrate in detail in this lecture so that you will be clear on how to use this algorithm on an example. We'll take an example and using that example, we'll see how to fill the DP table. The dynamic programming table, how can it be filled for one example problem? With this, it will be very clear for you how each step of the algorithm is working. Okay, let us start with this. We'll take an example. Before that, what were the steps that we learned in the last lecture? We learned that the first step is to have a DP matrix in order to solve the subset sum problem where you have a total of n numbers that are provided and you are said that you have to see whether there exists any subset of these n numbers which will sum to a particular value s. This is the problem. In order to solve this, we learned that we need a DP matrix. What should be the size of this matrix? It should be n plus 1 cross s plus 1 matrix. This is what we want. What should we do with this matrix? We have to do the initialization and after that all the remaining blocks of the matrix has to be filled as per the algorithm we learned. What is the initialization? While initializing, first thing we learned is DP I0. What does this mean? This means the first column of the matrix. This is your complete matrix. In this, whatever is the first column, this should all have the value true. Why should it be true? The reason is each column represent some particular value of sum. First column will correspond to 0, second one will correspond to 1, third one will correspond to 2 and so on up to a sum s. That is why you have s plus 1 columns in this matrix. What is the first column representing? It is representing sum is equal to 0. So whatever be the elements you are having, whatever be the n numbers, irrespective of that, 0 sum is always possible. Don't include any elements. Because of this, DPI0 which says you have I elements under consideration and can you make a sum 0 out of it? This is always true. So 0 sum is always possible. That is why the first column, this will always be true. What is the other initialization we have to do? Remember, this is for all I. For all values of I, you have sum is equal to 0. Sum is equal to 0 as true. You have a total of n numbers and you want to find a sum s. I'm just noting it down so that it stays in your mind. Other initialization is dp of 0j. What does this represent? For all j, dp of 0j, this represents the first row of the matrix. What does the first row say? First row says you have 0 elements under consideration, but depending on the column, you may want sum as 0, 1, 2, 3 and so on. According to this, with 0 elements, 0 sum is possible. But none of the other values are possible because you don't have any elements. How can you make a total sum of 1, 2 or 3? That's not possible. What will you do? This will be false for all j greater than 0. For j equal to 0, it is possible because it comes under the condition that sum required is 0. So in that case is possible. From the next column, sum is equal to 1, 2, 3, whatever. Those values are not possible. Because of that, these are the two initializations you have. Because of which you have the first column filled and also the first row filled. This is the situation right now. Next step is the most important step. Let me note it down here. What are these conditions? This is sum is equal to 0. This is the condition when number of elements equal to 0. Okay. The third step, what did we learn in the last lecture? What should you do in the third step? In third step, for each entry dpij, you have an option to either include the ith element or not include the ith element. You want a total sum of j, and for that you can either do it including the ith element or excluding the ith element. Here we learned that there are two conditions to be checked. The condition is whether the value ai minus 1, that is the ith element of this set that you have. From this set you want to take a subset. Whatever is the set of n numbers, from that the ith element, that is ai minus 1. Why am I writing I minus 1? Because it is 0 indexed. If a minus 1, if this is greater than the value sum or j here, at this point j is the total sum. In case the value of this element itself is more than the sum that you are looking for, then surely you can't include this element, because if you include it, you already know this total value is going to be above the sum that you want. So that particular sum j is not possible by including this element. It's because the value of this element itself is more than j. What will you do in this case? In this case, your updation will be dpij. How will you update dpij? You will update it as dp I minus 1 j. What does this mean? This means you know you can't include ith element. So what is the possibility then? Whatever was the value you found for I minus 1 elements, with I minus 1 elements, if it is possible for you to make a sum of j, then with I elements also it is possible. That means ith element is just useless in this case. If with I minus 1 elements you can do that, then with I elements you can do that, because you would just not consider the ith element. You will take I minus 1 elements and make the sum j. This is the first case. What is the other case we learned? In case a of I minus 1, if this value is less than or equal to j, in this case you have two options. Either you can include the ith element, and then with the remaining elements you should be able to make a sum which is equal to j minus value of ith element. Otherwise, what can you do? You can choose not to include the ith element and simply use I minus 1 elements and make a sum j. Both are possibilities. What did we learn? How should we write this? In this case, updation for dp should be dp of ij. How should you update this? For this, you have two possibilities now. One is, if you are not considering this ith element, then what can you do? You can write dp I minus 1 j. This is one possibility. Just with I minus 1 elements, if you can make a sum of j, then it's done. Otherwise, or this is a or statement, that is either this should be true or this should be true. Keep in mind, all these values, they are either true or false. It is a Boolean matrix that we are having. So here what did we learn? In case with I minus 1 elements, the value is true, then you will just copy true here. If it is false, you will copy false here. But this time, you have two options. Either if this is true or the second condition is true, in either of the cases, you will mark dpij as true. What is the second condition? In the first condition, we said in case we are not including ith element. In the second condition, we will consider the ith element. If ith element is already considered, then you have to take the value of dpi minus 1. This side it should be j minus a of I minus 1. Why is this j minus a of I minus 1? This is the condition that in case you are adding ith element, then with the remaining I minus 1 elements, you should be able to make a sum of j minus the value of ith element. If this is true, that is with I minus 1 elements, if you can make a sum that is equal to j minus value of ith element, then by including ith element to this, you will be able to make a sum of j. That is why if either this value is true or if this value is true, you will mark dpij as true. This is in case aij is greater than, less than or equal to j. This is our algorithm. What did we learn about this algorithm now? This is how you will go through the algorithm, and finally, what is the final answer? In the fourth step, I'll write the final answer. The final answer should be the last element dp of n S. This should be a final answer. If this particular block is true, that means there is a possibility to make a subset which sums to value S. Otherwise, such a subset is not existing in this set of n elements. This dpns is the last block in this table, which means it is possible with the given n numbers to make a subset of value S. If it is true, then it's possible. If this block is false, then it is not possible. Let us see how this is done. We'll take an example and let us see how exactly each block is filled. We'll take an array as example. We are having an input sequence. I'll call it A. In this input sequence, we'll have some numbers and then we'll try to see if some particular value is possible as a subset sum. Let the numbers be 2, 3. I'm just randomly taking numbers here. 13, 1, 16, 4 and 8. Let this be the set of numbers that I have. My total sum requirement S is equal to, let us say, 7. That is, my question is whether from this set of numbers is it possible to choose a subset such that that subset will sum to the value 7. This is the question. Let me put this in an array so that I can number. These are the numbers that I have. These will be different indices of the array. We are going to start filling the table. I'll just put the indices 0, 1, 2, 3, 4, 5 and 6. There are a total of 7 elements with you. And what do you want to see? Whether a subset of those elements can sum to 7. This is the question. Let us draw a DP table. This is the DP table that we'll have to fill. What will be the entries of the DP table? Here you should give the entries from 0 to 7 representing each sum value from 0 till 7. So I'll write 0, 1, 2, 3, 4, 5, 6 and 7. These are the sums. So final column, this will say whether a sum 7 is possible or not. In the rows, you should give the elements under consideration. So the first row will correspond to only the 0th index. Whatever is in the 0th index, only that element under consideration. Then it should be first index also under consideration, second index, third index. I'll drag this up. Then you have fourth index, fifth index, sixth index. Totally you are having 6 indices here. Let us now complete the table here. This is having like this. These are the columns in the table. What are we going to do? For each of the block, we need to mark true or false. What does true indicate? True will indicate that it is possible to have a subset sum where sum is equal to the value that is provided in the columns, these values, and the number of elements under consideration will be whatever we are writing for each row. So keep in mind that whenever we reach any particular row, that doesn't mean just that particular element is under consideration. That means all elements that are in the input list till that element, all those elements are under consideration. It's not just about that one element. All the elements till that point, all of them are under consideration. Okay. So keep this one point in mind. Let us start filling the table. What is the algorithm that we learned? Initially, we need a table which is n plus 1 cross s plus 1. That is what we have. We had sum 7. We have 8 columns, s plus 1 columns. We had a total of 7 is the number of items that we had. And here we have 0, 1, 2, 3, 4, 5, 6. Now, okay, we should have one more. 7 should also be there. Why should 7 be also there? Because we have 7 elements here. These indices are from 0 to 6. The first row, this 0 is not 0 index. It corresponds to the point which says 0 elements are under consideration. Not even one element in this list is under consideration. That is what the first row says. So we should have 7th row here. I'm adding one more row. This is our 7th row. Now let us start filling this table. How can you fill this table? The first rule is for the first row which says the first column which says sum is equal to 0, value is always true. That is what our algorithm says. So for the first row, the value is always true. Why is this always true? Because here sum is equal to 0. I'll just write it here that this is your sum, subset sum. And this says what are the elements, n elements, okay? Then what is it that algorithm is saying? It is saying the first row should be all false other than the first element. When j is greater than 0, then it should be false. This is because when you have no elements under consideration, 0 elements under consideration, it is not possible to have a sum of 1, sum of 2, sum of 3 or any positive sum is not possible when you have no elements under consideration. What are you going to do for the remaining elements? For the next element, starting from the first element it's having a value of 2. 2 is the value. What will you do now? First thing is, you will see whether 2 is greater than, less than or equal to the value sum you are looking for. At this point, when you are filling this block, your sum under consideration is 1. You are looking to see whether a subset sum of 1 is possible using only one element. Which is that one element? One element is 2. Using 2, is a subset sum 1 possible? First thing to consider is whether 2 is greater than j. Yes, it is greater than j because 2 is greater than 1. What will you do now? You have to go to dp I minus 1j. That is, without using this element, is it possible to make a sum j? What will you do? You will go to the block above. This says same value of j. That is, value of j is 1 here. Same value of j. Is it possible to construct that with all the elements till this point, but not this element? Without considering this element, is it possible to make the same sum? It says false. Here it is false. So you'll copy false here. Next one. Here the sum required is 2. Your element is also 2, which belongs to the second condition. That is, a of I minus 1 is less than or equal to j. What will you do? You have to see two columns. One is the same column that we had seen, the column above whichever point you are looking. Sorry, the row above the block, right above the present block, or I minus 1, j minus a minus 1. That is, in the previous row, I minus 1 means previous row, you have to see the block which corresponds to j minus the value of this particular element. So keep in mind, if your value is greater than the sum, then you simply have to copy whatever is there in the block right above it. That is what this says. Otherwise, you have to see what is there in the block right above it and what is there in the block in the previous row, that is in the column j minus a minus 1. That is, from j, decrease the value of this element and then see whether that block is true or false. Either of these are true, then you will mark as true. If both are false, then only you will mark as false. This is the only condition. As we keep filling, this will become very easy for you. What do you want to see here? One is the block right above it. It says false. Then the other block to consider is 2 minus 2, which means a sum of 0. So that is this block. This block says without this element, without the first element, is it possible to make a sum of 2 minus 2? That is, 0 sum is always possible. That is why it is true. That means here also it will be true. How is this true? Because if you add this element, then the remaining sum required is 0, which means that is true. So using this element 2, it is possible to make a subset sum of true. That is what this particular block is saying. Next is 3. Just with element 2, is it possible to make a sum 3? How do you see this? One is, you see the block above it which says with 0 elements is 3 possible? No, it is not possible. It is false. Then you see 3 minus 2 is 1. So for this particular row, you will see this particular column, you will see the row above the present row. So this position. This position says without 2, that is remaining elements if used, that is no elements used, Is it possible to make a sum of 3 minus 2, that is 1? It says it is not possible. Then you know this is also false, this is also false, then it should be false. Similarly, if you see all the remaining elements in this row will be false, it is false because you have only one element under consideration and you can't make all these sums. Next row. In next row, you have two elements under consideration. Which are the first two elements? 2 and 3. Both these are under consideration. So now you have 2 and 3. What does this say? 2 and 3 means this row you are going to newly add 3. So 3 is what you need for computation. Here I wrote 2, 3 so that you understand that it's not just 3 but 2 is also already considered. That is why I wrote it there. So is it possible to make a value sum of 1? Surely 1 is less than 3. So you can see both the possibilities. 1 is because see you know this subset sum is 1 and 3 is more than 1. So using 3 you are not going to make a sum of 1 because 3 itself is more than 1. So what should you do? You should only look one column, that is one particular block that is right above it, which says if you remove this third element, without this third element, is it possible to make a subset sum of 1? It is not possible, so you will copy. 2 is also less than 3, you will copy whatever is written above, which is true. Then 3, this time 3 is equal to 3. So you have two options. One is whether it is possible to make a sum of 3 without using this element, it is false, or with using this element, is it able to make a sum of 3 minus 3, which is 0. So this particular block, that is true. Sorry, it should be this particular block, the row above it. Presently we are considering this row, so you are looking at the row above it. This is true, this is false. So true or false will give you true. So this will be true. What about this one? Here you look the block above, it is false. Block 4 minus 3, which is 1. This is also false. False and false. So false or false will give you false. Similarly, all these will be false or false cases. Sorry, this can be considered, right? For 5, you have either this block should be true, it is not true. But 5 minus 3, that is block for 2. This is true. So true or false will give you true. If either of these are true, then you should write true. What is the next thing to enter? In 6, you have to see the block above it, which is false. 6 minus 3 is 3. Corresponding to 3 also you have false. So false and false will be false. Sorry, false or false will be false. Then 7. Here it is false. Then 7 minus 3 is 4. This is also false. So it should be false here. Next element to consider is 13. So you have 2, 3 and 13. I'm not going to write the elements here. Understand that 2, 3 and 13 are under consideration. 13 is the newly added element. With 13, is a sum of 1 possible? You know 13 is larger than 1. So whenever this particular value is larger than the sum you are looking at, what should you do? You should copy whatever is present right above. So false. 2 is also lesser than 13. So copy whatever is present above. So this is gone. Copy whatever is present above. True, true, false. I'm just copying whatever is written in the previous row because all these elements are lesser than 13. So there is no point wasting time there. Next element is 1. 1 is a small element. If you see here in the fourth row, is a sum of 1 possible? You should see 1 is the row right above it, the block right above it is false. Then 1 minus 1 is 0. Corresponding to 0, is it a true? Yes, it is a true, because of which true or false will give you true. So here it is corresponding to 1. Then for value true, the block above it is true. This or this. So you already have a true, so you can directly write true. What about this? Block above is true, so you can write true. Next one, the block above says false. So for 1, it is not possible to make a subset sum of 4 without using 1. That is, if you use all elements till 1, 2, 3, 13, it's not possible to make a subset sum of 4. But if you use 1, then 4 minus 1 is 3. Subset sum of 3 is possible with the remaining elements, which means subset sum of 4 is possible by including 1. So see the block above and the block this minus present element, that is 4 minus 1 is 3. So this is true, because of which it should be true. Here the block above is true, it should be true. Here again block above is false, but 6 minus 1 is 5, block corresponding to 5 is true, so you have true. Here for 7, block above is false, 7 minus 1, 6, that block is also false, so it should be false. All other elements are true for now. Next element is 16. 16 is the next element you have. What about 16? Coming to 16, 16 is greater than all the elements you are looking for, 0, 1, 2 up to 7. 16 is always greater. So including 16 is not an option. What will you do? This is corresponding to 16. Corresponding to 16, you can only copy whatever is present in the block above. So just copy true, 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 true and false. And I just copied because 16 is a larger number. What about the next one? Next number is 4. 4 is under consideration now. What should you do with 4? Initially 1, 2, 3. These are lesser than 4. So for these numbers, what will you do? You will simply copy whatever is in the above block. So true, true, true. Next one is 4. This is equal to 4. So you have two possibilities. Either the block above has to be true, or 4 minus 4, 0 has to be true. Here both are true. Whenever the block above is true, you can directly write, because it is an OR condition. The first condition is true, that means final answer is going to be true. So whenever the block right above is true, you can directly write true, because it is an OR condition. Next one, last one is false, which means without using this element 4, it is not possible to make a sum 7. But using element 4, you should see the block 7 minus 4, which is 3. Corresponding to 3, you have a true in the previous row, because of which here it will be true. That is true or false will be true. This is what we did. What about the last element? Last element is 8. Considering element 8, 8 is also larger than all these values. So you only thing you can do is copy above value, because including 8, it is not possible to get a value that is sum of 7 or anything lesser than 7, because 8 itself is larger. But you can simply copy whatever is above, denoting that you are not including 8. If it is possible to make that particular sum using the first 6 elements, then including the 7th element 8, also you will get that sum. Just don't consider while you are doing the subset. So true, 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 because I'm just copying the row above. It is all true. What is the final answer that you got? The final answer that you got is in the last block. What does this last block says? This last block will tell you that considering all the n elements, is it possible to make a sum of 7? That is, here the value of s is 7. Is it possible to make a subset sum 7 from these n elements? Considering all the n elements. Considering does not mean including in the subset. Considering means you have that element available for consideration. You can either include the element or not include the element. So if this is true, that means it is possible to make a subset sum of 7 using these provided 7 elements. Using these elements, you can make a subset sum of 7. This is what we learned about subset sum problem. One more thing. One more important thing is, we learned that the subset sum problem has a time complexity order of n into s and a space complexity order of n into s. Why is this? Time complexity is because you have to fill each entry of the table, and there are a total of n into s entries in the table. Why the space complexity is order of ns? This is because this whole table is additional space. It is having a space of order of n into s. In the next lecture, we'll see whether it is possible for us to improve on this time complexity. The point is, you can actually improve on this time complexity, because for filling any particular row, we are only looking at the row right above it. We are not considering any other rows. So instead of this matrix, we can use an array and make a space optimized approach for subset sum. See, the reason why I'm showing you table first is table is more logical. You'll clearly understand how this filling is happening. Once you're clear with the logic, that is, you know exactly how this algorithm is working, then if you see the array algorithm, it will make sense for you because you'll understand what that array is. You'll understand that that array corresponds to one particular row in this table, and that is logical. That's why in all our lectures in dynamic programming, I'm first doing it with the table. See, time complexity is the same. So our major component is covered there. Space complexity is the only difference. So the logic remains the same and will decrease the space. Next lecture, we'll do that space optimized subset sum.